Welcome to part 2 of charting with data in databases. This is the follow-up to the episode in which we wrote a custom XData method to get data from the database for our charting web application. And now we are ready to start building the web application with TMS Web Core. For all of this, my XData server, or our XData server, is running in the background on this URL. I picked localhost, port 80, root Flix. You might have like TMS XData. The important thing is the server has to be running while development. Having the server running in the background will make it easier to supply the correct values to the design time components, so you won't have errors showing up when you run your application that the server URL isn't there, or that you have missing fields or misspelled fields. This will all be taken care of by the IDE if you have the server running in the background while you do your development. Let's have a look what we'll develop in this video. Here you see the chart. It's the Google chart. We have a title. We have the zip code on the y-axis, and on the x-axis we have the number of students. And if we hover over these bars, we get the actual values. In the next video, we'll see how to implement the clicking for drill down. That's going to be in the next video. First of all, we have to take care of retrieving the data from the XData server, or retrieving the data out of our database. We're going to develop this step by step from the first step until the last. And we already created an XData school example group, and you see the web charting project is already in here. So still, I'm going to create a new project. I'm going to say add new project, and I'm going to use the Delphi TMS web. And we're going to build a simple TMS web application. Be aware that, of course, you could build a TMS web Electron application if you want a desktop application that runs on multiple platforms. Or, of course, you can also build a PWA application. That all lies in your hand, having these wizards available. Of course, after you have decided for one of the types, you can, of course, migrate a web application to an Electron application later. So when we click OK, we get a new project in our project group, and let me save that. I called the project chart live, and our main form, main form, I'll rename it here. I'll also give it a name, form main. So we don't have to work with unit 1, 2, 3. Sometimes you get really crazy side effects if you work with these standard names, even for demo purposes, because there's somewhere in your search path there might just be an old unit 1, 2, or 3. So I'm going on the safe side here with you guys. Let's see. So the only thing we need really on the design time that the user sees is the chart. So we type chart, and you see TMS Web comes with a T-Web Google chart. Of course, now with the recent release of Padua, we have the three-dimensional 3JS chart. And if I had installed FNC, we would also have the FNC chart, which is also a visual component that you can use with VCL, FireMonkey, and so on. Let's see, drop this on the form, and we're going to align it on client. So basically the whole browser surface. And we're going to name it chart. That's all we have to do during design time for the chart. Nothing is going to happen if we run this. So we need to set up the data connection. And if you have seen any of my previous XData videos, I always used non-visual design time components to set this up. I never do it just in code. So we need the connection. And the connection, of course, needs to be set to HTTP localhost port 80/Flix, and at that point we can set connect to true. And if the server wouldn't be running right now, we would also get an error message. Let me rename this to connection. Very important to note, setting this to true means if you start the application, the connection will be set to true as soon as the form is being initialized, or while the form is being initialized. That is key, meaning it happens before you can access the form yourself, meaning it's before the form on create event. So before you have any shot at the form connected will be true. That means you have to be really careful if you have dependencies to other controls invoking something. Those might not have been initialized yet. So be careful setting this to true during design time, or before you build or deploy your application, always set this back to false. Going on from here, we need, of course, a client, a web client. I've shown you previous examples with the web dataset, but we don't have this comfort because we're not accessing any of the entity classes. We're actually using one of the services or service methods that our X-Data server has to offer. We implemented this manually, so we need a web client, and the web client will give us methods to call methods on the X-Data service to retrieve the values. Let me rename the web client to client and set its connection to connection. Now the web client is connected to the connection, and that's all we have to do for design time. We now have to implement the method that retrieves the data from the web service or from the X-Data service, and we can't use the form onCreate event. We have to use another event, which means as soon as the connection is established, we want to retrieve the values. So we select the connection, look at the events, and there you find onConnect. This event allows us to interact with the X-Data service as soon as the connection has been established. When the connection has been established, we want to call our service method. The service method, just to repeat, I'm going to show it to you in the web browser, will look something like this. If you go to Flex Chart Service, this is the result that we will get if we call this method. Of course, we could do it using a simple HTTP component, using this URL, and then parsing the result. But this is not the way that TMS Web or TMS gives us. We will choose a way that's way more comfortable because you have ways to interact with the actual server. As indicated before, we use the client, and you see it has all sorts of methods to get entity sets, to put data, to post data, to delete data. But what we want to use is a method called raw invoke, which allows us to invoke service methods on the X-Data server. Our service method is called iChartService.get total students total. Even though I pronounce it total, it's still an A. Total students zip. So how do you get this name? It's actually pretty easy. Looking at your server, you see that we had the chart service interface, and the chart service interface is called iChartService. Then you add a period and add the name of the method. Be very, very careful. This is case sensitive. So if you put it like this, you have to put it like this in this string. Don't mess up the case sensitivity because this code is being translated to JavaScript, and JavaScript, unlike Pascal or Delphi, is case sensitive. So be very careful how you type in the name of your methods. The second parameter allows us to specify parameters. However, we don't have any parameters for this method. It's simply a method call without any parameters. So we specify nil. And the third one is key. And because this method hasn't been updated for anonymous method use yet, we specify a method that is being called as soon as the result from the X-Data service has been retrieved. That means we can't simply specify in this line here, handle results. This is not going to work because this call is being sent to the server, and at some point in the future we're going to get the result. However, this is non-blocking. That means your source code is being executed before the result is being received. So you can't handle results here because this is being executed before the results have actually been received. So what to do? You specify a method here that is being called as soon as the result has been received. With an @ sign, you say onResult. And now you need to specify the method onResult that is being called. And we do this as a local method inside of connection connect. So here we define a new method, which is called procedure onResult. And the parameter is, and this is something you have to look up in the documentation, response tx data client response. So this parameter allows you to ask anything about what has been delivered from the service. This could even be an error or whatever. It doesn't have to be just the data. There's more to this object. So define the variables, begin, end, and this is our local method that gets called as soon as the results are retrieved. Let's compile this. It should still work. It does. And I'm thinking while I'm typing this, if I can give you a short way of seeing that the result is actually retrieved. So let's look at response. And if we look at the response, we have the status code, which is hopefully 200. So if it's not 200, something went wrong. And here is the response text and the result. So let's do something crazy. Let's just display the response text on the screen. So we say show message, response text. So if you type it correctly, code completion can actually help us. Response text. And let's see what happens if we execute this. And right after the application loads, I didn't cut this. Here you see localhost says, and here is the result. And at some point, Google Chrome cuts off the show message. So you see, everything is working as expected. So this is actually the only downside we have compared to using the XData web dataset. We have no fields or anything. We actually have JSON to deal with. However, TMS provides classes that make it easy to parse such a result. Just for demo purposes, I'm not going to do any error handling. So I'm just going to add a command check status code, right? Because if it's not 200, you need to do something else. For example, if it's 404, it means the resource wasn't found on the server, that something went wrong. Or 401, 403, authorization issues, something like that. So check the status code first before you do what I'm doing now. I'm simply expecting the result to be perfect. So the first thing we need to do is set up our chart. So in case you wonder how the chart looks, chart is an object like any other. So even though it's taken from the Google Charts API, you still have a simple Delphi component that you can work with properties, events, and methods, of course. So charts series is where you can add series, and series contain values. A series is a line, a bar, or whatever, and a series contains multiple points. Is it called points? Yes, it's called point. And any point has like an X coordinate, a Y coordinate, and sometimes even a Z coordinate if it's a three-dimensional chart. So we're going to just use a two-dimensional chart, of course, to signify how many students attend school in a certain zip code. So let's specify a title for the chart. So we can say chart title, chart.title equals, let's see, students per school grouped by zip code. And if you ask yourself, Holger, why do you do this in code? Of course, I could also select this here, go to properties and select title here and enter it here. I just preferred it in code this time to have it all together when the chart is being initialized. Again, you can do whatever you want to do. You can also use the object inspector to implement all the properties. Of course, you can't do it with the values that are being retrieved from the web service. You have to do that in code because you have to iterate. Let's add a series to the chart. And for that, we need a variable called lSeries, which is of type tGoogle chart series item. How do you know what this class is called? First look, of course, documentation. However, I think in this case, the code completion isn't that bad. You see, it basically tells you, if you call add, that a tGoogle chart series item is being returned. Okay, so add, kind of like a tree view, same thing. You call add, you get an instance to the thing that you can modify that is being displayed in the chart. Chart type is a tGoogle chart type dot, and then here you see all the chart types that we have. I'm going to pick a bar chart, which is this one, and I don't even bother about the type. Code completion helps me there. lSeries dot title, and this is the series title. This is not the title of the chart, and this is students per. It shouldn't be students per. It should be students per zip code. And now we have to evaluate the result that comes from the web service. For that, we need a couple of variables. We need an array, and that is of type TJS array. It's a JSON array. It's an array of JSON values, and we always have one item that we analyze, and that is our JSON object. And then we have, remember the values that we have to look at. We have a ratio, it's a double value. We have a zip code, which is a string in our model. And finally, we also have a counter. I call it I. I never changed this behavior since learning Turbo Pascal years and years and years ago. The next call is, I would say, the most complicated call to understand. It took me a while reading the documentation, so I'm gonna do it bit by bit. So we have the response result, and the response result is of type JSON value. And the JSON value can be cast, and this is something you simply have to accept to a JSON object. So because we know it's an object in there, it's not just some value like an integer or something, it's an object, and we can parse this and or typecast this. And this JSON object, if we go to the code, what it looks like, you see that the first one is value. So this JSON object has the property value. So what we do is we say this result from property value, and we want an array, right? So we cast this to JS array. So and assign it to larray. So larray is the JSON array of the property value. Okay, let that sink in a little bit. Maybe go back in this video, look at the JSON again. So larray is now an array of these. This is one item, this is another item, this is another item, okay? So, and we can iterate this. So we can say for I equals 0 to larray, and guess what? It has a length property, kind of like in C#, -1. So you don't use length and larray in braces or a function call. You actually call a property which is called length. You have to subtract 1 because it's 0 based. Begin. I still believe I'm going to turn 39 years this year, not 40. Because I'm a computer scientist, I can claim it's 0 based. Let's get the item of the array, litem, equals. We cast to object again because we know it's an object on the array, larray. And the item is item I, and that's it. And now we can access all the properties of this litem. So we can say lzip equals, and we can cast this to string litem zip. And then we can get the ratio. We can cast this to double litem ratio. Forgot one brace. Okay. And now the final thing to do is we have to add this to the diagram or to the chart. So far we have added nothing. If we would run this, nothing would be added to the chart. So we say lSeries values add single point. Remember, we add to the series, not to the chart. Series has a values property with all the values, and that has a method which is called add single point, where we can add, as you can see, a value with a label, and the value is lratio, and the label is lzip, which is the zip code. We save this. Unlike with databases, we don't have to call any next or anything because we iterate an array, and that's it. Compile. Compile's fine. Let's run it. And we get an error message. What did I forget? Well, we see that reference array Google is not defined. So this should trigger something in your mind, because we use Google, and Google is something that's third party. Even though it's included with TMS Web Core, you have to right click your project, and then you can say manage JavaScript libraries, and there you should find something like Google Charts right here. So we say, okay, we want to use Google Charts, we run it again, and there you go, we have our Google chart. One thing to be aware of, if you add Google Charts to your project, you have to make a change and recompile. You really have to trigger the recompile, otherwise the reference is not being compiled into the project. So here we go. This is what we coded. We have the title of the chart, we have our zip codes as labels, and we have the ratios as the values. And of course we have the marking of the blue bars. Right now, nothing happens if we click on it, but you can see we have the hover and you get all the information. The best thing is this thing is responsive. That means if you change the size and it's animated, so you see, and no data is being retrieved ever again. This is a one-time thing, so you only request the data from the server once, and that's it. I hope you realized all that hard work that we had to put into the XData service method to build it for the first time, it paid off big time, because we were able to build a chart in mere minutes. I mean, I did extensive explanation for every step that I did. However, the chart was being generated just like that, and it didn't take any huge amount of work. You can imagine if you have multiple service methods for different kinds of data that you want to prepare for your customers, in addition to being able to sell the data service by itself, you can also pretty easily create a web application. And this web application can run, of course, on any platform. You can also create an Electron application, which is multi-platform, or you can create a PWA web application. So your options with TMS Web are endless. And I hope you saw how much using XData paid off in the end. In the next video, I'm going to show you how to add the drill down for the schools that actually produce these values inside of a pop-up window inside of the web application. Stay tuned.